Hi, I am Rishabh.
I am Sohum, and we are competing in the coder category.
We have used AI for determining the best strategy for battling COVID. In particular, we have used agent based modeling to simulate COVID 19 spread in a virtual world. As part of this project, we have learned Python based simulation modeling and machine learning techniques like natural language processing and AI vision.
We'll first talk about the effect of wearing masks. The probability of transmission of COVID through an N95 mask is 10%. So if two people are wearing those masks, chances of transmission go down to 1%. So guys, unless you're Batman, wear masks properly. So let's see how masks affect things in a simulation. We have three cities: A, where nobody wears masks; B, where half of the people do so; and C, where 3/4 of the people wear masks. Each population starts with 10,000 people. Cases in city A quickly shoot up and cover the entire population. The rise in city B is much slower and the total infections are lower than city A. Same for city C, but even more drastically. This graph shows the number of active cases for a given day. As more people wear masks, peaks of cases become smaller and are delayed. This avoids overloading hospitals. We also see that deaths of unmasked people are much higher than deaths of masked people.
For simulating lockdown, we'll first classify a lockdown into different types based on its intensity. No lockdown, mild lockdown, severe lockdown, and a dynamic lockdown, which can varyingly restrict the number of people coming together based on the current number of cases. City A will have no lockdown, City B will have a mild lockdown, and City C will have a dynamic lockdown. The blue, green, and red bars represent the number of cases for cities A, B, and C respectively. The cases rise fastest when there are no lockdowns, followed by mild lockdown, followed by dynamic lockdown. This graph shows the active cases over an 80-day period. As we can see, the curve is flattened the most in case of dynamic lockdown. Let's simulate the effect of vaccination. City A has no vaccination, City B has a vaccination rate of 0.4%, and City C has a vaccination rate of 1%. In contrast to no vaccination, there are far fewer cases for 0.4% vaccination rate and even fewer for 1%. This also reflects in the graph showing number of deaths, where 1% vaccination results in 35% fewer deaths than no vaccination.
To wrap it all up, we will look at a graph that compares all of the different measures we have looked at so far: varying amounts of vaccination rates, lockdowns, and masked percentages. As expected, the worst thing a city can do to battle COVID is not have any measures at all. Other measures have varying levels of effect on the number of infections and the number of deaths. But according to this simulation, the most effective measure against COVID is wearing masks. This means that the most effective measure against COVID is in our own hands. As we saw masks are pretty important, we wanted to see the public perception of wearing them. For this, we employed natural language processing. We wrote a Python script to take 10,000 tweets from Twitter regarding masks and trained an NLP model to identify people's sentiments. We used this data to plot a pie chart to see what proportion are positive, negative, and neutral. They're pretty even. This shows a lot of people are not taking wearing masks seriously.
So how do we solve this problem? By using AI vision, of course. We developed a program on Scratch that uses machine learning to check whether someone's wearing a mask or not. We use supervised learning to train this model with 350 plus pictures of people with and without masks. Here you can see me putting on and taking off a mask and the model detecting that.
This is the source code we wrote where all the magic happens. I will scroll entirely through it. You can pause and study the code.